When testing poles for energization, there are methods that can be employed without using a grounding rod. Firstly, the tickle stick method involves using a long insulated stick with a metal tip. To use this, touch the metal tip of the tickle stick to the base of the pole. If the pole is energized, the tickle stick will produce a tingling sensation and possibly a faint glow. Secondly, a voltmeter can be used without a ground rod. Set the voltmeter to AC volts with a range from 0 to 250 volts. Touch one probe of the voltmeter to the base of the pole and the other probe to a known good ground, such as a water pipe or a grounding rod on another pole. If the pole is energized, the voltmeter will indicate the voltage between the pole and the ground. However, it is important to consider safety first. Always wear appropriate safety gear, including insulated gloves and non-conductive footwear. It's important to note that the tickle stick method is not as reliable as using a voltmeter with a ground rod. The tickle stick might not detect all energized poles. The tickle stick method is best used as a quick way to test multiple poles if time is of the essence. Keep in mind that these methods only indicate whether the pole is energized or not, and they do not provide information about the actual amperage or grounding status of the pole. If possible, it is still recommended to use a voltmeter with a ground rod for more accurate and comprehensive testing. For additional context, the poles in question have a reported amperage of 32 amps going to the base with a supply voltage of 120 volts. The steel poles are not bonded and are fed with a 60 amp fuse. The primary concern is finding a method for quickly testing the poles without using a meter and grounding rod. It's crucial to emphasize the importance of electrical safety when dealing with potentially energized equipment. Working with electricity always carries inherent risks, and precautions should be taken to minimize the possibility of electric shock or other injuries. These are some key safety measures to implement. Firstly, always assume that a pole or any electrical equipment is energized until proven otherwise. Use appropriate personal protective equipment such as insulated gloves, safety glasses, and non-conductive footwear. Secondly, maintain a safe distance from energized equipment whenever possible. Avoid touching any part of the pole or any nearby objects while testing. Thirdly, use insulated tools and equipment that are specifically designed for electrical work. Ensure that all tools are in good condition and free from defects. Fourthly, work in a dry environment whenever possible. Avoid working in wet or damp conditions, as water can increase the risk of electric shock. Fifthly, be aware of your surroundings and potential hazards. Look for overhead power lines, underground cables, and other electrical equipment that may pose a risk. Sixthly, never work alone. Have a qualified person nearby who can provide assistance in case of an emergency. Seventhly, if you are not qualified to work on electrical equipment, seek the assistance of a licensed electrician. Do not attempt to perform any work that you are not comfortable with. Eighthly, before starting any work, to energize the circuit or equipment whenever possible. Use a reliable method to verify that the circuit is de-energized before touching any wires or components. Ninthly, always follow lockout/tagout procedures to prevent accidental re-energization of the circuit. This involves placing a lock and tag on the circuit breaker or disconnect switch to indicate that the circuit is being worked on. Tenthly, use a properly calibrated and functioning voltmeter to verify the absence of voltage before touching any wires or components. Always double-check your readings to ensure accuracy. These quick testing methods that don't rely on a grounding rod have limitations. The tickle stick, while convenient, provides only an indication of voltage presence. It doesn't give any information about the level of voltage, the amount of current, or the integrity of the grounding system. This lack of detailed information can lead to inaccurate assessments and potentially unsafe conditions. Similarly, using a voltmeter to measure voltage between the pole and a known ground, such as a nearby water pipe, can give a reading, but this reading might not accurately reflect the true voltage potential of the pole. The impedance of the ground path can affect the voltage reading, making it difficult to determine the actual level of energization. The steel poles themselves, if not properly bonded, can present a hazard. Bonding ensures that all metal parts of an electrical system are at the same electrical potential. Without bonding, a fault in the system can cause the steel pole to become energized, creating a shock hazard for anyone who comes into contact with it. Furthermore, the fact that the poles are fed with a 60 amp fuse while carrying a reported amperage of 32 amps raises concerns about the overall safety and integrity of the electrical system. A fuse is designed to protect against overcurrent conditions such as short circuits or ground faults. If the fuse is not properly sized for the load, it may not provide adequate protection, potentially leading to equipment damage or even a fire. A 60 amp fuse on a 32 amp load might seem adequate, but it's important to consider the inrush current of the load. Some electrical equipment draws a higher current when it is first turned on, and this inrush current can trap a fuse that is too close to the operating current. In addition, the age and condition of the fuse can affect its performance. Over time, fuses can degrade and become less reliable. If the fuse is old or damaged, it may not trip when it should, potentially leading to dangerous conditions. It is essential to periodically inspect and test fuses to ensure that they are in good working order. Furthermore, the fact that the poles are fed with a 60 amp fuse while carrying a reported amperage of 32 amps raises concerns about the overall safety and integrity of the electrical system. A fuse is designed to protect against overcurrent conditions such as short circuits or ground faults. If the fuse is not properly sized for the load, it may not provide adequate protection, potentially leading to equipment damage or even a fire. A 60 amp fuse on a 32 amp load might seem adequate, but it's important to consider the inrush current of the load. Some electrical equipment draws a higher current when it is first turned on, and this inrush current can trip a fuse that is too close to the operating current. In addition, the age and condition of the fuse can affect its performance. Over time, fuses can degrade and become less reliable. If the fuse is old or damaged, it may not trip when it should, potentially leading to dangerous conditions. It is essential to periodically inspect and test fuses to ensure that they are in good working order. The 120 volt supply voltage is a standard voltage for many electrical applications. However, it is still capable of delivering a dangerous electric shock. Even a small amount of current can be fatal, so it's important to take precautions to avoid contact with energized equipment. When working with 120 volt circuits, always use insulated tools and equipment, and avoid working in wet or damp conditions. It's also important to be aware of the potential for ground faults. A ground fault occurs when current flows through an unintended path to ground, such as through a person's body. Ground fault circuit interrupters or GFCIs are designed to detect ground faults and quickly de-energize the circuit to prevent electric shock. GFCIs are commonly used in bathrooms, kitchens, and other areas where there is a high risk of water exposure. In addition to the quick testing methods described earlier, there are other methods that can be used to test the poles for energization. One method is to use a clamp-on ammeter to measure the current flowing through the pole. A clamp-on ammeter is a non-contact device that can measure current without having to disconnect any wires. To use a clamp-on ammeter, simply clamp it around the pole and read the current in the meter. If there is current flowing through the pole, it indicates that the pole is energized. Another method is to use a thermal imaging camera to detect heat signatures. Electrical equipment that is energized will typically generate heat, and a thermal imaging camera can be used to detect these heat signatures. To use a thermal imaging camera, simply point it at the pole and look for any areas that are hotter than the surrounding area. If there are any hot spots, it indicates that the pole is energized. Ultimately, the best way to ensure the safety of electrical systems is to perform regular inspections and maintenance. This includes checking for loose connections, damaged wiring, and other potential hazards. By identifying and correcting these problems early, it is possible to prevent accidents and ensure the reliable operation of the electrical system. Regular inspections should be performed by a qualified electrician. A qualified electrician has the training and experience necessary to identify and correct electrical problems safely and effectively. When hiring an electrician, it's important to check their credentials and make sure that they are licensed and insured. It's also a good idea to ask for references from previous clients. In conclusion, testing poles for energization requires careful consideration of safety precautions, limitations of testing methods, and the overall condition of the electrical system. While quick testing methods can be useful for identifying potential hazards, they should not be relied upon as the sole means of ensuring safety. Regular inspections, proper maintenance, and the use of qualified personnel are essential for maintaining a safe and reliable electrical system. In situations like this, where steel poles are suspected of being energized and are not properly bonded, a comprehensive safety plan is crucial. This plan should include, firstly, a detailed risk assessment to identify potential hazards and evaluate the likelihood and severity of potential accidents. This assessment should consider factors such as the voltage levels, the condition of the equipment, and the presence of any environmental factors such as moisture or conductive surfaces. Secondly, the safety plan should outline specific procedures for testing and inspecting the poles. This should include the use of appropriate personal protective equipment such as insulated gloves and footwear, as well as the use of calibrated and functioning test equipment. Thirdly, the plan should address the issue of bonding and grounding. If the poles are not properly bonded, the plan should outline steps to correct this deficiency. This may involve installing bonding jumpers between the poles and a grounding electrode system. Fourthly, the safety plan should include provisions for training and communication. All personnel who will be involved in testing or working on the pole should receive thorough training on electrical safety procedures and the proper use of test equipment. Fifthly, the plan should include a process for documenting all inspections, tests, and repairs. This documentation should include the date of the inspection, the name of the person who performed the inspection, the results of the inspection, and any corrective actions that were taken. This documentation can be used to track the condition of the electrical system over time and to identify any trends or patterns that may indicate potential problems. Sixthly, the plan should address the issue of fuse sizing and protection. The fuses that are used to protect the circuit should be properly sized for the load and should be tested regularly to ensure that they are functioning properly. If the fuses are not properly sized, they may not provide adequate protection against overcurrent conditions. Seventhly, the plan should outline procedures for dealing with emergency situations. This should include procedures for de-energizing the circuits, providing first aid to injured personnel, and contacting emergency services. Eighthly, the plan should be reviewed and updated regularly to ensure that it remains current and effective. As new technologies and procedures become available, the safety plan should be updated to reflect these changes. A comprehensive safety plan, combined with regular inspections, proper maintenance, and the use of qualified personnel, is essential for maintaining a safe and reliable electrical system. In addition to the above points, it's important to consider the specific context in which the poles are being used. For example, if the poles are located in a public area, such as a park or sidewalk, there may be additional safety considerations. In these situations, it's important to take steps to prevent unauthorized access to the poles and to ensure that they are properly marked with warnings signed. If the poles are located in an area where there is a high risk of vandalism, it may be necessary to take additional security measures, such as installing security cameras or fencing.